So as you know, in the last class we have discussed so many things. Last class is just for a review purpose. This time going through for a few minutes. First we have discussed the definition of thermodynamics. That is consists of thermo plus dynamics. Thermo means energy and dynamics means transformation. And then we have taken some examples related to that, and how raw material is converted into the product. What do we need? We need the resources like material, energy, space, and time, and we have to optimize all those things. Means material, energy, space, and time, and to optimize those processes. First, we need to ask several questions that process is feasible or not, and if feasible, then what fraction of raw materials can be converted into the product, how much energy requirement is there, how much time, means all those resources we need to assess so that we can find out the best alternative, optimized alternative, best route, which requires less energy, less time, all those things. Still, that will be completing our target. Now, as far as process is concerned, first is unit operation, and then second is unit processes. So unit operation is something that where you don't find any chemical reaction like distillation. These are separation techniques basically. Distillation, absorption, extraction, and fluid flow phenomena, all those things, energy transfer, heat transfer, all those things will come into category of unit operation, and rest comes into the category of rest, that are related to chemical reactions, will come into the category of unit process. Chemical reactions is related to unit process. Now, all those things we have discussed, the need of thermodynamics and all, and then what are the principles of thermodynamics? Four laws. Zeroth law of thermodynamics, that will define the temperature. First law of thermodynamics, that will define the internal energy, and second law of thermodynamics, that will define the concept of entropy. Third law of thermodynamics will talk about absolute zero entropy, and and these four laws are experimental in nature. Logical reasoning would be there. Now, to study the thermodynamics, we talked about that we have two approaches: macroscopic and microscopic approaches. Macroscopic approaches needs macroscopic variable, and microscopic approaches will need microscopic, though those are more in numbers. So it's difficult to study thermodynamics microscopically, but yes, macroscopically we can study it better. So a macroscopic approach will come under the category of classical thermodynamics, and microscopic approach will come under the category of statistical thermodynamics. And then we talked about variables, state variables, etc. And I think SI units I talked about. Okay, and then process followed by yes, I have taken the example. So for thermodynamics analysis, we have to choose system and immediate surrounding we have to take, because in the surrounding that is far from the system will not have so much impact on the system. So we will consider only immediate surrounding for the thermodynamic analysis. Now, as far as property is connected property is considered, so any characteristic will become property of the system, and that will be converted into state, and the properties are related to energy changes. So property is the point function. So this should not be path functions. Z is equal to Z of xy. So perfect differential, I told you how to take this point function. Property is the point function. So thermodynamic property is the point function, means exact differential. Now, if there is a property, if something is property, then you have to think of property means the function, point function, right? Means exact differential. Now, intensive property and extensive property, and I talked about intensive and extensive property in detail, and then we talked about energy, kinetic energy, potential energy, and internal energy. Kinetic and some of kinetic energy, potential energy will be called the mechanical energy, and if you include the internal energy in it also, then it will be the total energy of the system. Now I have talked about all those things. Now this is the right time to proceed for the first law of thermodynamics. So revision is clear all to all of you. Tell me in the chat box, please. Revision is clear to all of you. हाँ, यहाँ तक क्लियर है सभी लोगों को, सुनाई दिया है? You can type in the chat box. Okay, it means okay. All right. So let's begin with the. Can I start the first law of thermodynamics? Okay. Someone can speak by unmuting your audio so that I can check in between that I am listening or not to you people. What's happening to my earphone actually? Oh, I can't be listening. Okay, so shall I start first law of thermodynamics? मैं क्या बोल रहा हूँ इस समय आप लिख कर दिखाइए चैट बॉक्स में, तब मैं समझ पाऊंगा कि आप एक्चुअली सुन रहे हो. फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स स्टार्ट कर सकते हैं. ओके ओके, गुड गुड गुड. सो नाउ आई शुड स्टार्ट. ओके, नाउ focus on the screen. So let's begin. So energy, taking back to this energy topic. Now, let's talk about some more things, and then for fundamental. If you talk about first law of thermodynamics, you will encounter work also, energy also. So let's talk a bit about work. All right, work. So what do you mean by work? Suppose work, it is represented generally in most of the textbook, W, and this W is scalar quantity. A scalar quantity. Now, you say that what is work? Work is said to be performed if some force acts through a distance. If some force acts through a distance. And let me tell you very clearly, through a distance, some force. Now two quantities, two keywords, some force. Now force is the vector quantity, and some distance, through some distance. And this distance is along the, F is, let me tell you this distance. Uh, we call it if it is with direction displacement, right? Line of displacement. So this is also vector quantity. Now since this is a scalar, these both quantities are vector. Work must include these two quantities. So what you will do? You will take dot product or cross product. Dot product will give you the scalar quantity W, right? So W is equal to F dot ds. So ds, now if you write this equation and F ds cos theta, you can interpret this in different ways. Like you can either put it with F itself, F cos theta ds. Now ds here is scalar. Or you can put it as F ds cos theta. Both ways. So what does it mean? F cos theta. First interpreting this one. So F cos theta means what? Suppose you are applying the force on this block and displacement on this block is in this direction. ds. Now this force is acting in this direction. So the component of force, suppose this is the angle. So component of the force acting along line of displacement. So F का component इस direction में क्या होगा? That you have to take. So F, this is F. Or better you can take, you may get confused. Suppose this is the block and you are applying the force in this way, F. Okay, and displacement is happening in this direction, ds. Anything can happen. Now see the line of action of the force like this. Extend this line of action of the displacement and angle is theta. So force का जो component ds direction है that is F cos theta. So F cos theta, suppose we want to write it in not in theta form, so I will write F and this suppose this vector ds. Now I did not write here F cos theta, but you must understand here F is the component of the force in the direction of ds. So better to write with dot product. Okay, so this is very clear. Some book write like this F dot ds or F dl. So don't confuse. F dl means dl would be the displacement. Now this is the component of force, not force. Component of force in the direction of displacement. Now stress is on the term in the direction of displacement, means perpendicular to the displacement force. Suppose this force is acting now in the direction of displacement. In the direction of displacement there is F cos theta and perpendicular to that F sin theta. But F sin theta, but in this direction there is no displacement. So 0, you will multiply with 0 and you will get the 0 work. So effective work could be this only, means force in the direction of displacement multiplied by the length of the displacement. Okay, so this is the thing that you must understand with respect to work. Okay, So let me write some more thing. Now, with respect to this W, sign convention also. Right here, I must tell you, sign convention. Sign convention generally different book follows different, but stick to one. अब मैं साइन कन्वेंशन में बता देता हूँ क्या है इसमें. मान लो हम ले रहे हैं, कुछ भी ले सकते हैं, इट डिपेंड्स ऑन. By convention, work is regarded as positive when the displacement is in the same direction as the applied force. जिस डायरेक्शन में हम फोर्स लगा रहे हैं उसी डायरेक्शन में अगर डिस्प्लेसमेंट भी हो तब हम वर्क को पॉजिटिव लेते हैं. ओके, चलिए. तो ये चीजें, बिकॉज इन दोनों के बीच एंगल क्या होगा उससे आप समझ सकते हो. अब यहां पर क्या है, निगेटिव कब होगा, जब डिस्प्लेसमेंट, applied force and and displacement both are in opposite direction. So work is regarded as positive when the displacement is in the same direction as the applied force, and negative when they are in opposite direction. So this is the convention. Now I will illustrate through this by one example. Suppose I am putting some container right here, and suppose I filled some fluid with some volume B. Suppose some gas is there. So mostly you will find in thermodynamics those works which accompanies a change in volume of a fluid. Okay, work that is related to change in volume of the fluid. Change in volume of the fluid. और मैकेनिकल वर्क में क्या था, डिस्प्लेसमेंट, जस्ट वन डायरेक्शन में डिस्प्लेसमेंट की हम बात करते थे, बट इसमें वॉल्यूम में चेंज होगा, उससे वर्क ज़्यादा you will encounter. Okay, so the work which accompanies a change in volume of a fluid is often encountered in thermodynamics. I must take one example. Okay, so change in volume may be of two types. Volume, when volume will decrease of the gas in this system, compression, compress कर दो तो decrease कर जाएगा, और एक्सपेंड कर दो तो एक्सपेंशन ऑफ द फ्लूइड होगा. तो इसका मतलब क्या हो गया बच्चों, तो कंप्रेशन मींस इंक्रीजिंग द प्रेशर एंड एक्सपेंशन मींस डिक्रीजिंग द प्रेशर. यहाँ पे हम एक पिस्टन भी लगा देते हैं, इससे आप पिस्टन से ट्रैक कर सकते हो इनिशियल पोजीशन पिस्टन की क्या थी और फाइनल पोजीशन क्या थी पिस्टन. Now the force exerted by the piston on the fluid is equal to the product of the piston area and the pressure of the fluid. Now the displacement of the piston is equal to the total volume change of the fluid divided by the एरिया ऑफ द पिस्टन. अब यहाँ से हमें क्या करना है, देखो इस वॉल्यूमेट्रिक वर्क को हमें डिफाइन करना है, बट हम जानते हैं कि F फोर्स होगा एंड देन F डॉट डी एस, बट यहाँ जानते हो दोनों सेम डायरेक्शन में हैं तो cos 0 1 हो जाएगा, तो वी कैन राइट F ds, isn't it? Displacement. Now this displacement that is in one direction only, how can you get it? वॉल्यूम में चेंज जो गैस के होगा, तो वॉल्यूम को अगर एरिया से डिवाइड करोगे then you will get only one dimension, that is displacement. So ds we will get right from here, and then force, for force you can measure here pressure of the gas. So pressure अगर मेजर है तो pressure per unit area will give you what, force. Now, this way we can get force per unit area will give you the pressure. Pressure, you will get the pressure. Now, force you will get from pressure into area. So, pressure into area. Now, this FDS, so we can write W, suppose infinitesimal distance this have covered. DS, displacement of the piston. Through expansion we are considering first. So dW in this displacement work, what you will take first? Force is PA. All right, force is PA because P is equal to F by A multiplied by what? Displacement. So how much displacement would be there? So change in volume of the fluid divided by area. ये ds s की जगह पे हमने क्या लिख दिया? b by a और चेंज के लिए हमने लिख दिया d. समझे? ds s के जगह पे क्या लिख सकते हैं? वॉल्यूम बाय एरिया. सो डिस्प्लेसमेंट आ जाएगा because some cross sectional area is moving in this direction. Okay, so it will intercept this type of volume. So you will divide with this if area, then you will remain with this this dimension. That is the dimension of displacement. So d of b. Now since this is a fluid, b total volume, the total volume upon area. So the force exerted by the piston on the fluid is equal to sorry. So this PA would remain same, PA we know, and this ds we can write dV of A. All right. So the displacement of the piston is equal to the total volume change of the fluid divided by the area of the piston. Here A is the area of the piston. So in this way you can calculate the force exerted by the piston on the fluid. Okay, this is equal to nothing but the product of the piston area. Force is nothing but the product of the piston area and the pressure of the fluid, right? So this thing you understand. Now let's move to, so this is dW. Now tell me, what should be the direction? Negative, positive, negative, sign convention negative. I said that if force applied and the displacement both are in opposite direction, then there would be minus sign. So here see, both are in opposite direction or same direction. So force you are applying, force अगर इस डायरेक्शन में अप्लाई हो रहा है तो आप बताइए मुझे कि this is the what we are calculating actually. The force exerted by the piston we can calculate how. पिस्टन कितना फोर्स लगाएगा फ्लूइड पे, वो कैसे कैलकुलेट कर सकते हैं? कितना प्रेशर है फ्लूइड का और पिस्टन एरिया से मल्टीप्लाई कर दें तो हमें पता चल जाएगा कि कितना फोर्स एक्सर्ट कर रहा है. अब बात आती है कि जो डिस्प्लेसमेंट है पिस्टन का वो कितना होगा, तो डिस्प्लेसमेंट डी ऑफ v by a. Now I told you that this minus sign, so by convention if applied force and the displacement in opposite direction, so actually we are calculating this fluid was expanding. this fluid was expanding. Now if this fluid was expanding in this direction, displacement is in this direction, and we are applying, we are calculating force by the piston on this system. So you see the displacement and force applied by the piston is in opposite direction. So here you will take dW is equal to minus PA dVTi now you must अगर आपको W find out करना है then you must integrate it. So A is constant. So A is constant area of the piston. So you can take outside. So A will cancel out. So this minus P dV. So this is the work done. Now this is still dW because अभी हमने integrate नहीं किया है, और W you will get by integrating. Suppose B1 to B2, then P dVT. VT means total. So the minus sign in these equations are made necessary by the sign convention adopted for. And the piston moves into the cylinder so as to compress the fluid. The applied force and its displacement are in the same direction. The work is therefore positive. Now the minus sign is required because the volume changes. Volume change is negative. Once you move the piston, see, actually this is the system. Suppose this is the system. Let's be very clear about this sign convention. We are applying the force through piston, right? So if you apply the force, then dV, volume will shrink. So change in volume would be negative. Well, but you see that displacement of the fluid is in the same direction in which we are applying the force by the piston. So work should be positive. This work should be positive as per convention. But here you will, if you calculate, then dV is negative. Pressure is always positive. So this quantity will come out negative. So you must multiply it by negative sign. So to make it positive. So this will follow the convention of the work. समझ आ गया कि नहीं आ गया? अब सपोज एक्सपेंशन होगा तो कैसे लिखोगे? सपोज दिस इज द फ्लूइड and expansion is happening. The fluid reaches right here. So for the expansion process, applied force and its displacement, we are applying the force in this direction, suppose, and expansion happen, fluid go in this way. So if expansion happen, both are in negative direction. So volume increases, so volume will increase, final volume. So dB would be positive. But work done, dV would be, in this case, dV would be positive, and minus sign is required to make the work negative. So again, this minus sign is required. So to understand this, this is the very general formula. dW is equal to minus PdV. So this equation expresses the work done by a finite compression or expansion process. Now to understand graphically this thing, let me tell you. Suppose the compression of the gas is happening. This is P and this is V. Gas के लिए है तो गैस के लिए आप जानते हो PV is equal to constant at constant temperature. So this compare with XY is equal to constant. This represent the rectangular hyperbola. The rectangular hyperbola ये ऐसे बनाते हो. This type of graph you will get or not. Now tell me, suppose this is P, so this state, suppose this is initially you start from this stage 1 and you reaches to this stage 2. So what will happen? Now here you will have the B1 volume, total volume at the state 1, and at this place you will have total volume V2. Similarly here P2 and here P1 pressure. All right. So this is the BT graph, PV graph. So just understand that this shows in this direction we are moving. Volume is decreasing in this direction. So it is the graph that is showing the compression of the gas from point 1 to point 2. Compression of gas from point 1 to point 2. Now this path relates the pressure at any point of the process to the volume. Okay. Now work required is given by, since you know W is equal to what? dW is equal to what? Minus P dVt, and W is what? Minus P integral B1 to B2 dVt, isn't it? Now P you can take inside if you want. नहीं P तो inside रहेगा, ये पूरी को integrate करोगे ऐसे. Okay, let me make very clear. So dW is equal to minus P dVt. W you can integrate, so minus sign take outside, P dVt. Now this is nothing but the graph area B1 to B2. Area under curve P और B के बीच जो curve होगा, area under the curve B1 to B2. So what work will represent? This work is proportional to the area under the curve, this PV curve, right? So this area, if you this area will represent the curve. Sometime I will suppose someone will give you this graph and say calculate the work done in this process going from 1 to 2. So just calculate this area. This area integral will give you the work done. So this thing you must understand with respect to work. Now, in thermodynamics, in summary, I would like to tell you, in thermodynamics, we especially talked about expansion or compression work, right? And to bring this expansion or compression work in the format of F dot ds, mechanical work, ds, the S, that is the displacement, we have converted, since there is volume shrinkage or volume expansion. But if you divide volume expansion or shrinkage with the surface area, you will get the displacement. Okay, volume has 3 dimensions, area has 2 dimensions. So you will get, if you divide, you will get 1 dimension, the displacement dimension. So in this way, you can get converted the work, displacement work in the mechanical sense, in the thermodynamical sense, expansion work or compression work. So this PdV work I told you. So especially since this is the compression or expansion work, so it will become the PdV work. dV means change in volume. So this in thermodynamics, wherever you see the W, immediately it must come into your mind that it must be 99% chance would be PdV work. Now suppose PdV work 99% chance, but it is the subset of, because we have calculated it from the mechanical formula of work, okay, that F dot ds. So up to this point of time, are you people are clear about the work done, how to calculate the work done and all that? Sign convention, the beautiful sign convention is that if force and displacement are in same direction, then positive. If force and displacement are in opposite direction, then obviously you will take the work negative, isn't it? Because cos theta is negative. If it is in opposite direction, then it could be negative. Now understand or not? Send me in the chat box. Work समझ आया? कोई कहीं प्रॉब्लम? अगर यहाँ पे प्रॉब्लम नहीं है देन आई प्रोसीड फर्दर। देखो एक एक चीज समझते चलो, यहीं पे क्लियर करते चलो। नाउ लेट मी प्रोसीड फर्दर। आई विल टॉक अबाउट इन अ वेरी सिमिलर फैशन, मींस वर्क अब हमें समझ में आ गया। अब हम बात करते हैं एनर्जी। क्यों एनर्जी की बात करेंगे हम? क्योंकि एनर्जी इज नथिंग बट द कैपेसिटी टू डू वर्क, कैपेसिटी टू डू वर्क। अब हम देखते हैं वर्क अगर फाइंड आउट कर ले जाए हम तो कैपेसिटी फाइंड आउट कर लेंगे तो एनर्जी हो जाएगा। ठीक है, सो फर्स्ट आई विल टॉक अबाउट मैक्रोस्कोपिक एनर्जी। इसमें क्या क्या आएगी? काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी। सो लेट्स टॉक अबाउट दैट काइनेटिक एनर्जी। काइनेटिक एनर्जी, व्हाट इज काइनेटिक एनर्जी? अब मैं बता रहा हूं काइनेटिक एनर्जी, ध्यान से सुनना। एक बॉडी है आपके पास जिसका मास m है, इस पे फोर्स F लग रहा है। सपोज ये F फोर्स के लगने से ये बॉडी डिस्प्लेस कर गई, डिस्प्लेसमेंट dl इन द सेम डायरेक्शन, डिफरेंशियल डिस्प्लेसमेंट dt टाइम में। तो वर्क डन कैसे निकालोगे? वर्क डन इज W, F and dl both are in same direction, so cos 0 1, so F dl हो जाएगा। W is equal to F dl। now Newton's second law से, Newton's second law you know, what is Newton's second law? Newton's second law, what is Newton's second law? F is equal to ma, m you know, and acceleration, so put it there, ma dl, so this is W। अभी हम इसको dl डिस्प्लेसमेंट हुआ F फोर्स लगाने से, फोर्स लगाएंगे तो एक्सेलरेशन होगा, F इज इक्वल टू, फोर्स लगाएंगे तो एक्सेलरेट बॉडी करेगी तो काइनेटिक एनर्जी, डी एक्सेलरेट करेगी तो डिक्रीज इन काइनेटिक एनर्जी, एक्सेलरेट करेगी तो इंक्रीज इन काइनेटिक एनर्जी। नाउ दिस A, how you can write A? A is change in velocity, so dv over dt. So can I put it there? dv or dt or b velocity, sometime you represent du over dt, u से वेलोसिटी लिखते हो तो कुछ भी लो, कोई फर्क नहीं पड़ता। तो यहाँ से देखो क्या है, u, v, w are the components of in x, y, z direction. Sometimes in fluid mechanics you have studied. So suppose this is the x direction, so we are taking du. Okay, no issue with that. So let's calculate this m, and this is du over dt. All is well. Then dl. Now I will rearrange m, okay, and dl by dt and du, change in velocity, to represent this change in velocity. Now since the definition of velocity is what? The dl is displacement. In this figure you see dl is displacement. The displacement per unit time is velocity. So this is what? U, instantaneous velocity at any point of time. So this is mu du. Now this equation, now you can integrate. So this is dl displacement को हम माने थे dl displacement हो रहा है तो dw वर्क, so this is dw. Now to get the w, how will you get the w? To integrate this equation for finite change in velocity. So for infinitesimal change in velocity du, for finite change in velocity you must integrate it from u1 to u2. Suppose velocity is changing from u1 to u2. So what you will do? Integration. So mass of the object would be same, m, and then u du, put it, u1, u2. Now tell me what would be this m. U square by 2 will be this, its integration. Put it, put the upper limit. So u2 square by 2 minus u1 square by 2. ठीक है, तो ये वर्क है, समझ आया? वर्क इन फाइनाइट चेंज इन वेलोसिटी, वेलोसिटी में चेंज करने पे ये वर्क आ रहा है ड्यू टू चेंज इन वेलोसिटी u1 फ्रॉम u2। हम अगर वर्क फाइंड आउट कर लें तो यही तो चेंज इन वेलोसिटी से काइनेटिक एनर्जी निकल के आती है। तो W is equal to m u2, take m inside, u2 square by 2 minus m u1 square by 2। इसको हम, ये चेंज है m u स्क्वायर बाई 2 का चेंज है, तो हम डेल्टा करके ऐसे भी लिख सकते हैं, सम टाइम आई विल राइट m u स्क्वायर बाई 2 भी लिख सकते हैं। इनमें चेंज, दैट इज वर्क means, and this is half mu square। okay, so लॉर्ड केल्विन ने इंट्रोड्यूस किया था। so this is by definition what it should be, kinetic energy, because change in kinetic energy will lead to work done। so capacity to do work is energy, right? so ये work W is related to this energy, so this is EK, kinetic energy, that is half mu square। hope this is very clear। now if you see, this equation will have the significance। what significance this equation will have? This equation shows that work done on a body in accelerating it from an initial velocity u1 to final velocity u2 is equal to change in kinetic energy of the body। means energy at a point has capacity to do work। Converse means, conversely, if you are accelerating a moving body, deaccelerating a body, okay, by the action of resisting force, the work done by the body is equal to the change in kinetic energy। so these things that you must understand। now another thing I would like to tell you, the potential energy। another form, potential energy। now not only you understand the kinetic energy is half mv square, but its derivation also। now potential energy, suppose this is due to position, so suppose a mass m raised from initial position z1 to same mass m but final position z2, it has been raised this mass। okay, how will you raise? because gravity act downward, so you will have to apply the force on this body to move it upward। okay, and that force must be, that upward force must be at least equal to the weight of the body। okay, must be exerted on it with a weight जो है mg वेट से तो के बराबर, तो कम से कम फोर्स लगाना ही पड़ेगा इसको यहां से यहां तक मूव कराने, कम से कम। and this force must move this body through a distance z2 minus z1। Now this force mg we are applying. So F is equal to, first you need to calculate force. A is what here? G, gravitational force due to position. पोजीशन तो ग्रेविटेशनल फोर्स, ग्रेविटेशनल पोटेंशियल फील्ड में तो ए डी वी और डी टी यहाँ पे क्या हो जाएगा? जी हो जाएगा. अब g is the local acceleration of gravity. So the I am talking about now this minimum force you need to apply. Minimum because mg we are taking. इसके बराबर या इससे ज्यादा फोर्स लगाना पड़ेगा आपको, तभी आप मूव करा सकते हो इस पोजीशन से उस. तो मिनिमम फोर्स कितना लगाना पड़ेगा? mg. तो मिनिमम वर्क, मिनिमम फोर्स के करेस्पॉन्डिंग मिनिमम वर्क भी आएगा. तो चलो देख लेते हैं कि मिनिमम वर्क कितना होगा बॉडी को रेज करने में. तो फोर्स और डिस्प्लेसमेंट इज z2 माइनस z1 एंड फोर्स इज mg, z2 minus z1. So this minimum work you need to do, ये मिनिमम है बेटा, मैक्सिमम नहीं. तो mg z2 ब्रैकेट खोल दो जैसे पहले खोला था, mg z2. Now to change the position of the object, now you can put it like this also, mgz. Now this mgz is the potential energy. Now to change the position of the body from z1 to z2, you need to do minimum work w. You need to do the minimum work w. Okay. So this mgz energy is nothing but the potential energy. The potential energy is equal to EP is equal to m g z or mz g. Anyhow you can write. So just understand, we are raising the body. Okay. So this is something that you understand about the potential energy. Now I would like to tell you energy conservation. That is first law of thermodynamics. Energy conservation. I told you that potential energy and kinetic energy together will constitute mechanical energy. Potential energy, kinetic energy. So first law of thermodynamics, very simple form. First law of thermodynamics. We need to develop. So if a body is given energy when it is elevated, then the body conserves or retains this energy until it performs the work of which it is capable. So an elevated body, her potential energy say, in elevated body to fall freely gains in kinetic energy. What is losses in potential energy, so that its capacity for doing work remains unchanged. For freely falling body, this means suppose freely falling body है, उसमें दोनों होगा, freely falling body ये दोनों होगा, kinetic energy and potential energy. So change in kinetic energy plus change in potential energy would be equal to 0. Conservation of mass. So this is nothing but m u2 square minus m u2 square by 2 minus m u1 square by 2. और पोजीशन z1 to z2 पोजीशन पे क्या काइनेटिक एनर्जी क्या थी? mz2g minus mz1g is equal to 0. So this is and this principle is applied only for the purely mechanical process. Thermodynamic process meaning a purely mechanical process. तो ये चीजें आपको पता चल गई कि एनर्जी कंजर्वेशन एंड सिंपलेस्ट फॉर्म आई टोल्ड यू. And in the next time I will the work, energy conservation and heat. I must tell you something about heat. First law of thermodynamics. Then I will start formally in the next lecture. Now heat. Now from experience we know that अगर आप hot body को cold body के contact में लाएंगे, the hot energy would be transferred from hot body to a cold body. So hot body will reduce its temperature and cold body will increase its temperature, means it will become warm. So a reasonable view is that something is transferred from hot object to cold one, and we call that something is heat. Thus we say that heat always flows from higher temperature to lower temperature. Now this leads to the concept of temperature as the driving force for the transfer of energy as heat. Now more precisely, the rate of heat transfer from one body to another is proportional to the temperature difference that I told you in heat transfer course, proportional to the temperature difference between these two bodies. When there is no temperature difference, there is no net transfer of heat. In the thermodynamics, when there is no temperature difference, there is no net transfer of heat. In the thermodynamic sense, heat is never regarded as being stored within a body. Okay, like work, it exists only as energy in transit. Okay, energy in transit from one body to another or between a system and surrounding. When energy in the form of heat is added to the body, it is stored not as heat but as kinetic and potential energy of the atom and molecules making up the body. Okay, so heat transfer करेंगे आप किसी बॉडी को, so heat के रूप में ये हीट के रूप में ही नहीं ये स्टोर हो जाएगा बॉडी में, ये काइनेटिक एनर्जी और पोटेंशियल एनर्जी मॉलिक्यूल्स का जो है उसमें कन्वर्ट होकर के ये स्टोर होगा. तो हीट ट्रांसफर होता है, समझने की बात है, हीट स्टोर नहीं होता है. सो नेचर क्या है हीट का? ट्रांजिएंट नेचर है. ओके, ट्रांजिएंट नेचर, units of heats and all those things, you know. So this thing I told you very clearly in the heat transfer course. So heat, work, energy. Now up to heat, I told you heat, work, energy. बताओ यहां तक सबको क्लियर है? एंड मैकेनिकल फॉर्म ऑफ फर्स्ट लॉ ऑफ कंजर्वेशन क्लियर? एनी डाउट सो फार? बोलो कोई प्रॉब्लम? बोलो बोलो. So I think I should stop beta right now, and then I will discuss first law for mechanical system. I discuss now first law for thermodynamic system discuss in the next lecture. Thank you so much. मैं attendance अभी float कर रहा हूँ. Within 5 minutes you can see and mark your attendance. Thank you so much.
Thank you, sir.
Thank you, sir.